Hello, this is section 8.1, points, lines, planes, and angles. So there's some basic terms we should go over. A point, a point, line, and plane are three basic terms in geometry that are not given a formal definition, yet we recognize them when we see them. A line is a set of points. Any two distinct points determine a unique line. So all you need is 2 points, and that's how you can define a line. Any point on a line separates the line into 3 parts, the point and 2 half lines. All right, so any point on the line, for example right here, separates the line into 3 parts, the point itself and the left side and the right side. So there's 3 parts. The array is half a line, including the endpoint, and a line segment is a part of the line between 2 points, including the endpoints. So let's take a look at some of these. Let's take a look at these examples. Here they are. This is called the line. As you can see, it's a double-sided arrow, and this is a symbol that we use in notation. Array only has a single-sided arrow. It can either be pointing to the right or pointing to the left, as you can see. And just make sure that the endpoint is at the correct letter. So the endpoint is with A, and over here the endpoint is with B. A line segment has 2 endpoints, and so this is how you would denote that. We can think of a plane as a 2-dimensional surface that extends indefinitely in both directions. So it'll extend indefinitely that way and also indefinitely that way. And you only need 3 points that are not on the same line, so non-collinear, to determine a unique plane. Two lines that are in the same plane that do not intersect are called parallel lines. So that's 2 lines that do not intersect, as you can see. A line in a plane divides the plane into 3 parts: the line itself, and one side of the plane, and the other side of the plane. Any line and a point not on the line determine a unique plane. So here's a line. Actually, let me do that over here. Here's a line, and a point not on the line will determine a unique plane. So you can imagine a surface that would where this line would be on and also the point would be on. So that would be a unique plane. The intersection of 2 distinct non-parallel planes is a line. So here you have 2 distinct non-parallel planes, and as you can see, they intersect at a line. 2 planes that do not intersect are said to be parallel planes. So for example, plane GHF is parallel to plane ABE. These 2 planes are parallel. An angle is a union of 2 rays. As you can see, you have one ray here, a one-sided arrow, and another ray over here, another one-sided arrow, and they have a common endpoint. That's how you define an angle. All right, so this is how we denote that. The angle can be written as, that's not correct. It would be, there's different ways you can write the name of this angle here. You can write that angle B, or you can say angle ABC. So angle ABC, or you can say angle CBA. As long as the common endpoint is in the middle. All right, the vertex is the point common to both rays, so this is called the vertex. The sides are the rays that make the angle. These are the sides, and they call this one the initial, and this is the terminal. There are several ways to name an angle. So we already went over the ways that we can name it. This way, or this way. The measure of an angle is the amount of rotation from its initial to its terminal. So here's the initial side, and here's the terminal side. The measure of the angle is given by this measurement here. As you can see, this would be about 50 degrees. you would go with the ones on the numbers on the bottom, not the numbers on the top. Angles are classified by their degree measurement. Right angles have a measure of 90 degrees. An acute angle has a measure that's less than 90, and an obtuse angle has a measure that's greater than 90 but less than 180. And a straight angle has a measure that's equal to 180. So here they are. These are the definitions we just talked about. A right angle is 90 degrees. An acute angle is between 0 and 90. An obtuse angle is between 90 and 180. And a straight angle is equal to 180. Adjacent angles are angles that have a common vertex and a common side, but no common interior points. Complementary angles are two angles whose sum is 90 degrees. Supplementary angles are two angles whose sum is 180 degrees. So here we have an example. It says in the figure, we see that the measure of angle ABC is 31. Let me just fix these. Angles should be this symbol, not the rectangle that you see. All right, so they say in the figure, we see that measure of angle ABC is equal to 31. They're telling us that ABC and CBD are complementary. That means they add up to 90. Determine CBD. And then they also want us to determine CBE. So let's go to that example. Here it is. So CBD, they want us to find this angle here. So CBD, the measure, you put a little m for measure. The measure of angle CBD is going to equal to, well, since these two angles are complementary, that means they have to add up to they have to add up to 90, as you can see by that little square there. So I'll call it x. So x plus 31 must equal 90. So if you subtract 31 to both sides, you're going to get 59 degrees. All right, so we figured out CBD. Now we got to figure out CBE. CBE would be this one. As you can see, it's an obtuse angle. Well, this has to be a 90-degree angle. So we know that this is 90 and this is 59. So 90 and 59, if we add those together, will give us the angle that we need. So the measure of CBE is going to equal to 90 degrees plus 59 degrees, which is equal to 149 degrees. So we got the solution to both of these angles. So that's the angle we just found. All right, a new definition. When two straight lines intersect, the non-adjacent angles formed are called vertical angles. So here's an example. These are two straight lines that intersect. Their non-adjacent angles are called vertical angles. So 1 and 3 are vertical to each other, and 2 and 4 are vertical to each other. And they turn out to be congruent. That means that they're going to be equal. So angle 2 will be equal to angle 4, or the measures will be equal, and measure of angle 1 will be equal to measure of angle 3. That's what they say here. They have the same measure. So I'll write that. Measure of angle 2 is equal to the measure of angle 4, and the measure of angle 1 is equal to the measure of angle 3. So now we have a line that intersects two different lines at two different points is called a transversal. So you have two lines, and then you have a transversal. A transversal cuts across two other lines. So this is called a transversal line. Special names are given to the angles formed by a transversal crossing two parallel lines. So now line 1 and line 2 are parallel. So this is the notation we use. Line 1 is parallel to line 2. That means parallel. And you have a transversal, So now we're going to have special names. On the next slide, you'll see the special names to these angles. So these two angles are called alternate interior angles. As you can see, they're alternate and they're on the interior of these two parallel lines. All right, and so they actually turn out to be equal in measurement. So angle 3 will be equal in measurement to angle 6. And now we have over here, we have alternate exterior because they're on the exterior of the parallel lines. So 1 and 8 also have the same measurement, and so do 2 and 7. Corresponding angles are the ones that are on the same side. And so this one would be corresponding to 5. 2 would correspond to 6. 3 would correspond to 7. And 4 would correspond to 8. And corresponding angles are also congruent, so they have the same measurement. When two parallel lines are cut by a transversal, alternate interior angles have the same measure. That's what we just said. So do alternate exterior angles have the same measure, and corresponding angles also have the same measure. So now we can actually do an example. It says the figure shows two parallel lines cut by a transversal. Determine the measure of angle 1 through 7. So we're given this angle 8 is 52. Notice that angle 6 is vertical. Vertical angles also have the same measure. So angle 6 will also be 52 degrees. So, and then we have, let's see, this angle and this angle are corresponding. 52 corresponds to 4, or sorry, angle 8 corresponds to angle 4. And we know that those are also congruent or have the same measure. So let me do this. 1, 2, 3, 4, 5, 6, 7, 8. We already know 8. All right, so we got 6 is 52 because of vertical angles. These are vertical angles. All right, 52 and 4, these are corresponding, so they're also equal in measurement. So 4 and 52 have the same measurement. So 4 would be 52 degrees as well. Okay, we have alternate interior angles. We already know that those are equal in measurement. All right, notice that this is a straight angle. So they're supplementary. These two angles have to add up to 180. So whatever angle 5 is, it has to add up to angle 6, and they have to add up to 180. So what we can do, so angle 5 would be 180 minus 52, which would be, what is that? Let me double check. That's going to be, I think it's going to be 128. Yes, that's 128. All right, so this would be 128 for angle 5. And then you have alternate interior angles. Angle 5 and angle 3 are alternate interior, and those are congruent or have the same measure. So angle 3 has to be 128. Oh, I made a mistake here. 128. I meant to say angle 4 was equal to 52, not angle 3. Okay, so we got that angle taken care of, 128. And then as you can see, these are vertical and these are vertical. So angle 4 and angle 2 have the same measurement. So angle 2 has to be 52. And then angle 1 and angle 3 have the same measurement. Those are vertical, so 128, 128. And we're left with number 7. Angle 7 has the same measurement as angle 5 because they're vertical, so 128, 128. Oops. And that will do it for all the angles that we're looking for. So we already did it, and that completes this section.